experience. And I'm going to give credit where credit's due. Is Dr. Nonaker still here? Dr. Nonaker invented this acronym, SGRE, and I borrowed it from him. He had one of these programs 10 years ago, and I thought, well, you know, that's kind of cute, so we're going to do the SURE program. And then, to my dismay, I Googled the SURE program, and there's at least 20 other SURE programs across the country, which are REUs that also use this program, but that's okay. It still sounds cute. So the focus is, as you all know, solid-state devices for electronics, photonics, and magnetics technology. I'm the program director. Dr. Wong is my co-director, and I'll say more about that in a minute. Our program administrator is Amanda Harris, and our graduate student is Mira Seif, and I'm going to introduce these people that are here as we go forward. So this is what today's plan is. Part of it we've already done. First is to check in. Everybody got badges. You know, you met your mentors and your grad student mentors and mingled a little bit, ate a little bit. And so I'm going to introduce the program to you. I want everybody to sort of know where this comes from and why it exists and who's paying for it. I'm going to introduce all of you guys. I've got a chart with your name. I'm going to have everybody stand up and say something, and I'll tell you what when we get to that point. I'll introduce the faculty and grad student mentors. Mostly, I think, the mentors of the grad student mentors. I think I'm the only actual faculty mentor that showed up, so maybe they're going to wait and come for lunch and get free food. Then we'll introduce the staff, talk to you about some administrative details, and then questions, and hopefully I'll have answers for you. And at that point, you know, you can feel free to ask anything, and if we don't know the answer, we'll figure it out. And then we'll have lunch. It's going to be brought in. It's being catered by Airmark. We'll see what they bring us when they bring it. And then the idea is you'll begin the SURE program with your faculty mentor, which means your faculty mentor, grad student mentor, will carry you off to the lab and start doing great things. So a little bit of background about this. This is actually officially an REU program, a Research Experiences for Undergraduate program, which is sponsored by the National Science Foundation. That's this particular award and grant number. And NSF has been doing REU programs for quite a few years. In fact, Dr. Nonaker, who's our interim department chair, who I borrowed the SURE name from, was telling me that they actually had an REU program that started back in 1993. And then I think they had another REU program. And there are probably at least 2 or 3 running on campus in other departments as we speak and all over the country. And the idea, you know, I think NSF's primary idea is they want more and more students to be motivated to go to graduate school. And so the idea of the program is to give you a taste of what grad school is like and try to prepare you for that and let you find out if that's really, you know, what you want. And hopefully most of you will want that. Our focus is on electronics, photonics, and magnetics. And developing an REU program, you know, one of the questions is what are we going to focus on? You don't want to make it too narrow, because NSF doesn't like that. You don't want to make it too broad, because if it's too broad, you don't really have a cohort experience. And so we focused it on some areas that are related to what Clemson emphasizes. Clemson has many emphasis areas, several emphasis areas that research is sort of umbrellaed under, and one of them is advanced materials. And so we took a materials to device approach. And there are a lot of researchers on campus that do research from basic materials all the way up to devices and even circuits and systems. And so there's a connection there that we're trying to build upon. So we have this materials device approach. And most of what you guys have been doing will either be related to materials or something that, I like this phrase, I like to borrow phrases from other people because I'm not very creative, but John Bellato, who is one of the faculty mentors, like, although Courtney's going to probably do most of the mentor, but he used the word, we work on device-y things. And so a lot of what we do is device-y, which means maybe you're not actually going to build a device, but you're going to make a material and characterize it that's crucial for that device. And sometimes you might actually make a device. Sometimes in my lab, we put layers of materials together, and you could call them devices. It's sort of a gray area of what a device definition is. But that's sort of the approach we're taking. This is a very interdisciplinary REU program. Oftentimes REU programs are limited to one department, and within that department, one focus area within that department. This one's very broad. We have faculty from ECE, electrical and computer engineering, material science and engineering, bioengineering, physics, physics. We have students in all those areas. We have at least one chemistry major and one biology major. It's very interdisciplinary. There's a lot of cross-pollination of ideas, and that's because in this area, in these three areas, and the dicey things are very interdisciplinary. You can't do it without physics and chemistry and material science and electrical engineering and applications and all those areas in bioengineering. And most of the research I've done since I've been at Clemson has not been, in fact, I don't collaborate with any people in the ECU department directly. They're all in other departments, in all these departments at one time or another. So one of the challenges was to convince NSF that this wasn't too broad. Some of the questions were, it's going to be so broad, the students won't have anything in common. And it was blatantly obvious to me that that wasn't the problem. The challenge was to convince them, and evidently we did, because of the candidates. So anyway, one of the things we're going to try to do is get you guys to see how all this stuff is interconnected. And there aren't sharp division lines between different majors. An electrical engineer and a physicist aren't in opposite ends of the universe, like maybe an accountant and a pharmacist might be. And so it all overlaps. And that's one of the things we want to have you guys experience. And part of the plan, too, is for you guys to experience what it's like to be a grad student. You're going to be put in your mentor's lab and working with their grad students and working on projects. And it will be very similar to what grad student life is like. It will just last 10 weeks instead of years. So a few details. The official start date is today, May 19th. The end date is July 23rd, so it's a total of 10 weeks. There are 10 undergraduate students. 2 are Clemson students. 2 Clemson students, stand up for a minute, because I'm going to make use of these guys a lot because they go here. They know the campus, they know the town, they know the area, so latch on to them. They will be very helpful to you. The other 8 of you are from other universities across the country, and I'm going to list that in a minute. There are actually 11 faculty mentors because a lot of us collaborate, but one of those 11 is on sabbatical this summer, so there is a lot of collaboration between all of us. So you probably recognize this chart. I had it up there just to help you at the beginning. But here is a list of all of you guys, your school, your major, or at least most of your majors, so you have multiple ones, and there's only so much space I can put on there, and your faculty mentor. And so what I'd like to do is I'm going to go through each list and sort of, read your name and who your mentor is, and then ask you to get up and say something just for a minute, like, where you go to school, what your major is, what you hope to get out of the RU program, anything you want to say, just so we get to know each other. Because one of the things we want to do, I want you guys to get to know each other. Last year, our RU program, the 10 students really connected together well. It wasn't because of anything I did or anything anybody else did, it just happened. And so I'm hoping that happens again this year, and that really made the so-called cohort experience a lot better. So let's, don't be shy when I call your name, just stand up and say something so we can all get to know you. First student is April Campy from the University of North Texas, and her faculty mentor is Thompson Mentor.
I'm April Campy. I'm going to the University of North Texas. If you don't know where that is, it's right next to Dallas in Texas. I'm electrical engineering. I'm getting a minor in business and math. And I'm going to be starting my junior year this fall.
Next student is Matthew Bird. Clemson, and his faculty mentor is Eric Johnson.
Hey everyone, I'm Matt, and I go to Clemson, as Dr. Harrell said. I am a junior in electrical engineering.
And then we have Brittany Elliott, whose faculty mentor is Dr. Giuseppe Ely.
Hello, I'm Brittany Elliott. I go to Park Atlanta University. In the fall, I'm going to be a senior in Park Atlanta, in Atlanta, Georgia.
Max Gallant, and his faculty mentor is me.
Hi everybody, I'm Max Gallant, and I'm majoring in materials science at the University of Utah, and I'm not Mormon. That's the first question that I always get.
It's funny when you said that, I swear what ran through my mind, sometimes I'm gonna have to subtly ask you that question. Now I don't have to. And I should have said this before I went through, if I butchered your name, forgive me, because I'm sure I'm going to, so far it's been easy. Our next one is Michelle Greenow.
Greenow.
Okay.
Hi, I'm Michelle Greenow. I'm from California. I go to school at Wagner College, which is in New York City, so I'm all over. I'm a chemistry major with minors in math and bio, and I'm going to be a senior.
We have Maddie Hines, whose faculty mentor is Singleton.
It's his, but yeah.
Oh, sorry.
Yes, it's fine. Yeah, so I go to Clemson, cross country. But I'm from Orlando, or I'm really from McNary, which is 45 minutes north of Orlando. I'm studying chemical engineering with concentration in biomolecular engineering, and I'm also pre-med.
And I know I'm going to butcher your name, but it's Dana.
Joaquin.
Joaquin, okay.
Hi, I'm Dana Joaquin. I'm from New Jersey, but I go to Temple University, which is in the city of brotherly love, Philadelphia. So it's definitely different here. I'm not used to all the quietness. I'm used to like the police cars running down the streets and everything. I'm a major in electrical engineering with a concentration in bioelectronics. Yeah.
I think I forgot to mention her faculty mentor is Sean. Next we have Ethan McClure, whose faculty mentor is Sean.
Hey everybody, I'm Ethan. I'm from Rhode Island. It's pretty small. It's not Long Island, as a lot of people usually think. So it's around Massachusetts and Connecticut. And I'm majoring in electrical engineering and math.
Next we have Nathan Smith, whose faculty mentor is Chad Sasalik.
Hi, I'm Nathan. I go to Georgetown. I'm a physics major, not computer science minors.
And last but not least, I'm probably going to butcher your name too, Jenna Touche. That's a joke.
I'm from Michigan. I go to Eastern Michigan University. I'm an engineering, physics, and art major, a minor in mathematics. A lot different down here than it is in Michigan. Everybody's really nice and it's really warm.
Although not so warm today. And I also forgot to mention
You think
her
so?
faculty mentor. Okay. This is a list of the faculty mentors. What I'm going to go through is I'm going to state faculty mentor, and if you are here, which most of you aren't, great. If not, hopefully you have a surrogate. So if you're a grad student mentor out there and I call your professor's name, just stand up and say who you are and who you're standing in for. So we have Dr. Sundar Kim. Let's see here.
Hello, I am Chung Sang Park. I am postdoctor in the EC department, working with Professor Song Kim. Nice to meet you. Everyone.
And the next person, notice I've got two, John Bellotto and Courtney Kucera. John technically is the faculty mentor, but really Courtney is. So,
Hi, I'm Sarah, Material Science and Engineering Department. We work out at AMRL. Dr. Bellotto just took the Vice President of Economic Development for the university, so his research priorities have kind of shifted. So now I'm more running the group, but he still oversees what we do.
and several of you will be working with faculty mentors that are housed out at the research park, and Courtney is a wealth of information about what goes on out there and how to get here and how to get back. And so maybe when we're having lunch and socializing, talk to her. We'll definitely take care of those issues. Then we have Lynn Chu. I think I saw him.
Hi, I'm Lee. So we work at AMRL. So we're mainly working on integrated photonic device, laser diodes, different optical devices, and welcome to Clemson.
And next, we have Chad Sasalik of Physics and Astronomy. I know he's not here, and I don't think he has any is there anybody here representing Chad Sasalik? Well, that would be me then. Dr. Sasalik's in the physics department. He and I collaborate a lot. In fact, our two students are going to be working together quite a bit. I'm going to take care of him for the next week because it just turns out that Dr. Sasalik and I think all of his grad students are gone this week to a conference, and so it's fortunate that we work so much together. So he needs to be in my lab anyway, so that will work out for him. And next we have William Sean.
He's not here. I'm Sam Bearden. I'm the PhD student. We're over in the bioengineering department in Rhodes, so you don't have to go out to AMRL for us. Yeah, we focus on nanotechnology for biosensing applications.
And we have Thompson Mefford, who I see is here.
Thompson Mefford, material science. I'm actually housed at the AMRL as well. My group mainly focuses on magnetic nanoparticles, a lot of polymer synthesis, a lot of particle synthesis, so it's a synthetically heavy group. Looks forward to hanging out with all you guys in summer. It's good to be here. I always like summers in Clemson. They're fun. There's a lot of stuff to do. We'll play outside. If you talk about playing outside, come see me. So.
Sounds good. You can be the social director.
I don't know about that. they met it well. So.
The cruise director. Next, we have Eric Johnson. I think I saw.
Hi, welcome to Clemson. I am a postdoc under Eric Johnson. I'll be working with Matt, also housed out at AMRO, like so many of the other faculty. A lot of our work tends to deal with micro-resonant devices in both the infrared and visible.
And we have Tony Giuseppe.
Yeah, he's not around, but I'm Coyote currently. I'm a PhD student in his lab for bioengineering, and our lab mostly focuses on working on biosensors, implantable devices, and such things. And yes, we're also kind of out at the research part.
And Igor Lizanoff is I guess you could say, the 11th faculty. He's on sabbatical this summer, so he's only indirectly involved, and he and I collaborate quite a bit together. Then Ping Shan Wang.
I'm Ming. I'm working with Dr. Pijamo. Our work is mainly to design high sensitivity microwave sensors, and we are on the third floor of this building. Welcome to Clemson.
And finally, we have me, and I do a lot of work in solid-state devices and materials, and the emphasis this summer that my students will be working on is in collaboration with Dr. Soslik in the physics department, where we have what we call a highly charged ion beamline that produces very energetic particles of ions in a very high charge state. It has some fascinating implications when it comes in contact with solid materials in their many applications, and so we'll be working on specifically the effects of such charged particles on solid-state devices and what we can do to actually fabricate devices using this beamline. So that pretty much goes through the faculty mentors. I want to say several things about the grad student mentors. And I probably don't need to say this now because, as you saw, most of the people that stood up were grad student or postdoc mentors. And I met with these guys near the end of last summer's RAU, and we realized we really should have done this at the beginning. And so we did this year. We met last week and talked a lot about what their role is. And I realized, and I should have known this anyway, if you'd asked me, I would have said, but I realized last summer when I worked with my RAU student and my grad student, that my grad student did most of the work. He spent most of the time, training my RAU student and helping him along with this project. And I think that's largely the way it works in all cases. And it's the way it works when I get a new grad student. I give him to my experienced grad students and have them train him. And I oversee what's going on. And so the grad student mentors are very, very important. You'll probably spend more time with them than you do your official faculty mentor. And that's not a bad thing. It's the way it has to be, and it works pretty well that way. And I should caveat that with, I'm using the term grad student mentor loosely because some of the assistant mentors are not grad students, they're postdocs or research associates, or they're PhDs. But I just mean the person that stands in for the faculty mentor. So you'll get to know some of these guys. And I mean, I'm not going to go down here and read the list because you won't remember it. I'm actually going to send out, once I put it together, a chart that has everybody connected to their faculty mentor and their grad student mentor, and everybody can see where everybody is, and I think that would be a good idea. But you can see that we have a faculty mentor, excuse me, a grad student mentor or a postdoc mentor for every student. And these are some of the projects that you'll be working on. And I don't know, I think it might be kind of tedious if I went through and rate those, but I'm going to send this out so people can see. And I think it's a good idea for you all to know what you're working on. And one of the things that I hope happens is as you guys get together, after hours, and whether it's social events that we've planned or just things you guys do together and you're just chatting, you'll talk about what you're doing. It'll be beneficial to all of you to know what's going on. But so one thing I do want to talk about with respect to these assistant mentors is what their goal is. And you guys that are out there will recognize this. This is exactly the same slide that I threw up when we talked last week. And it says official because I actually put this in the proposal that I submitted to NSF to get this funding, that this is what we were going to do for grad student mentors. And I didn't really train them last year in this, and so I corrected that this time. But I think it's helpful for everyone to know, the students, the grad student mentors, and the faculty mentors of you that are out there, this is what your assistant mentor's role are. One is help orient the REU students to the faculty mentors lab and research program. Just give you an example of that. Max and, Nathan, when we're done, I'm going to take them back to my office and talk to them for about 30 minutes, 40 minutes. Then I'm going to take them downstairs and tour my lab, and then I'm going to hand them to Daniel, and I'm going to say, see if you have any problems, and he's going to train them on my equipment over the next few days. I'm, of course, going to check in a lot, but part of the REU student's job is to get familiar with the lab and the layout of the lab and the equipment, and the grad student mentor will be very instrumental in bringing them up to speed. Two, guide and mentor REU students under faculty guidance on their individual projects, because you'll be working together on those. The project that my student will be working on is the same general area that the grad student mentor is going to be working on. Three, provide a resource to assist the REU student in all aspects of the REU program. That's one of the reasons I met with the assistant mentor, is to give them an idea of what they need to be doing. And you'll be there for your guidance and your advice. Collaborate with REU students in addition to the faculty mentor. It's really kind of a team. The faculty mentor, the grad student mentor, the REU student, and in many cases other grad students will be in there too, and we all work together as a team.